Well, hello again, guys. Um, round two. Okay, so here is, this is the next lecture, right? This is an introduction to A&P, but also we're going to cover some anatomical terms here as well. So we'll knock this out. This is going to be super fun. Going to do some fun demonstrations, and you guys are going to get to see me dance, but not really, right? So I don't dance. No, maybe I do, but you'll never know. So we're going to do a little bit of demonstration here of some anatomical terms and break it down. Another dance term. Sorry, guys, it's the medicine. It's this COVID, it's the COVID stuff and the Tylenol and the Mucinex, and it just does stuff to you. Okay, guys, I think you can see my screen. Maybe you can't. Let me make sure I shared it. Did I? Negative ghostwriter. I did now. Now I shared it. For those of you that know me, bless you. Thank you for putting up with me. Okay. All right, guys. An intro to A&P, but also directional terms. My dog just dropped his ball. He's like, play with me. No, I'm not going to play with you right now. But maybe I will. Okay. All right, guys. A&P. Here we go. So this is an introduction to anatomy, physiology, and directional terms. So clearly, right, anatomy, this is the structure of the body, right? The structure of body parts, organs that make up the human organism. So anatomy equals structure. Okay, physiology. Okay, this is the study of the function of the human body, right? And the structures that make up the human organism. So we talked about the relationship between structure and function. Anatomy often, because of the way that that it is positioned within the human frame, within the human body, lends itself to function, lends itself to its physiology. And we'll talk more about that as we get on into further lectures. But believe it or not, as biological entities, as biological creations, right, we actually, the smallest unit, right, of life is a cell, right? All of us come from atoms, molecules, macromolecules, and cells. That's what we are, right, biologically speaking. All the way up to obviously tissues, which is a collection of cells, organs, which is a collection of tissues, organ systems, which is a collection of organs. Need I go on, which then turns into an organism, which is you and I, right? The lovely people that are watching this video right now. Okay, we're all pretty cool. Okay, here's the deal. All of us as people, right, as human beings, and even biological life in general, has a desire, right? No, excuse me. I did not have a desire to cough right then, but it happened. Okay, so we have a desire, an innate drive to stay in homeostasis, right? So the structure and function of the body is geared to help us stay in homeostasis. Homeostasis is defined as the maintenance of a steady state. Okay, homeostasis maintains life. That's what it does. Okay, now here's the deal. Homeostatic mechanisms generally function with a very simple three-part mechanism. Okay, a receptor, okay, which is essentially a nerve ending or something that helps me pick up a stimulus from the outside, a control center. It'll send that impulse up to the brain and spinal cord to be interpreted, and then an effector. Okay, so that's either a motor, a motor nerve, like a neuromuscular unit. It's a muscle, it's a nerve, or it's a gland. I either feel it, pick it up, touch it, move it, right, or move myself, or I have a gland that secretes something, right, spits something out. All right. So what are the things though, right, that are essential to life? Obviously, water, food, oxygen, heat, and pressure. We need it to live. Okay, without water, we would become dehydrated. We would not be able to live. Without food, the metabolic processes in our bodies would not be possible. They would not have the fuel to complete them. Without oxygen, we would suffocate. Obviously, without heat, we would not be able to, continue to form chemical reactions, and we would not be able to regulate heat as well, obviously. So regulation of metabolic heat to the skin, temperature control, and then pressure. Without pressure, our lungs would not fill with air, right? And we would not be able to breathe on our own, right? And so that is, these five things are essential to life, right? Okay, so receptors, for example, let's just some quick examples of receptors. Thermoreceptors, okay? These sense temperature, right? And these will sense temperature. These are generally nerve endings, generally type A fibers with very, very fast conduction velocities. The control center here is the hypothalamus of the brain. Well, JK, in this example, we're actually talking about a sweat gland, which is the effector, right? Baroreceptors sense pressure. The control center there is in the brain and brainstem and spinal cord. It's a very primitive feedback loop, right? Mechanoreceptors and muscles, also in ligaments and joint capsules and tendons, right? Control center there is the brain itself, the cerebrum, cerebellum, right? And the effector there is a muscle, right? That helps us move to adjust our position in space, right? Chemoreceptors, okay? For example, if we're in an environment where we have too much carbon dioxide, okay, too much carbon dioxide, the chemoreceptors actually on the walls of our lungs and on the walls of our vessels in the alveoli will pick those things up. They will send a signal to the brainstem, to the pons and the apodictic center in the brainstem, and we will start to breathe. We'll start to breathe more to pull in more oxygen, right? And the effector there is the lung. It's another organ. Sorry, guys, it's just popped up on my screen right now. I don't know if you can see that. If you can, I'm sorry. It's getting in the way of your thing, the lecture. So I apologize for that. Okay, get out of here. Okay. Save there. Okay, sorry, guys. All right, negative feedback loops obviously return us to homeostasis. Okay, an example of that obviously is glucagon in the liver being produced, blood glucose levels rise, right, in order to keep us at homeostasis, right? Obviously, if our blood glucose actually rises too high, then our pancreas actually secretes insulin, which unlocks the key and allows the glucose to actually be transported into the cell, right, and thereby lowering our blood sugar and keeping us in homeostasis. Okay, what's an example of a positive feedback loop? Okay, what about shivering? Okay, shivering, it's crazy. All right, so let's say our body temperature falls. Let's say we're outside on a cold Minnesota day, and it's cold outside. We're walking home from the store in the snow. We slip and fall, we get our heads and we pass out, and we're laying in the snow for like 20 minutes. Well, our body temperature starts to drop, and our core body temperature drops below 100 degrees, right? So ultimately what happens there is the body senses, right, that our body temperature is low, therefore sends a signal to the hypothalamus, which then induces shivering, right? The muscle activity from the shivering, right, produces metabolic heat, believe it or not, which then raises the core body temperature and allows us to hopefully kind of move back towards being normothermic. For those of you that are/will be my athletic training students, you guys will learn a lot about that, discussing heat illness, obviously, and cold-related injuries. It's a crazy cool mechanism. This guy, he looks, I don't know how to describe him, but let's learn some anatomical terms and directions. All right. So obviously, guys, there are different ways to describe anatomy, believe it or not. Okay. The way that the vast majority of us in our medical training learned anatomy was actually regional anatomy. Okay, if you've ever taken a gross anatomy course, the anatomy that you took at Gustavus most likely was regional anatomy. Pardon me. Okay, you were learning the regional structures, muscles, ligaments, tendons, nerves, vessels, right? All of those things you were learning regional anatomy. For now, here's another thing, right? That's regional anatomy. That is the most common way to learn anatomy, right? Functional anatomy, though, however, as a clinician, like if I'm seeing a patient, right, and we're doing a movement screen, right, I might be able to more adequately relate to that patient's movement and describe it to them by utilizing functional anatomy. Okay, what's an example of functional anatomy? Well, I described to the patient a movement pattern by which the glutes and the lumbar spine contract basically at the same time to help maintain a stable core, right? And in doing so, I've described a functional anatomical relationship to the patient, right? And obviously there's systemic anatomy. This is most often used by physiologists. An example of this, okay, for example, is the digestive tract. All right. A a physiologist will tell you, if you talk to them about systemic anatomy, they're going to tell you, well, you know what? Your digestive tract actually starts in your mouth with your teeth. So your digestive tract includes your mouth, teeth, salivary glands, your obviously esophagus, stomach, large and small bowel, and your rectum. So yeah, that's an example of systemic anatomy, typically concerned with the function of an organ system. Okay, guys. So there are obviously, like we talked about, and there's actually more. There have been examples, just like with medical terminology, there have been examples to try and systematize anatomical terms. One of those is called the Terminologica Anatomica. And so that is one kind of effort that's been made to attempt to systematize anatomical directions, structures, and names. Okay. So according to the Terminologica Anatomica, there are 7,635 anatomical terms, individual structures that can be further divided into directions, planes, and cavities. I'm sorry. So let's talk about those. Okay. This is where I'm going to stand up and we're going to do a little bit of demonstration. All right. Okay. So for example, you can see the guy here on the slide. Okay. He is standing up. He's showing us his hands. He's in the anatomical position. And if you can see, maybe I'm going to move my screen down just a touch. That way you can see my hands. Okay. So for example, here's my hands. Okay. I'm in anatomical position. The front half of my body, this is the anterior half of my body. Okay. The back half, on the other hand. Okay. This is the posterior aspect of my body here. Okay. Okay. So anterior, front side. Okay. Also known as ventral. Okay. I've got a bigger ventral side than most people my age. I need to work on that. And then we have a dorsal side or a posterior side. Anterior, posterior. Okay. I'm back in anatomical position. It's crazy. You guys would never, by the way, see me in my pajamas. I don't always lecture in my pajamas, but when I do, it's because of COVID. Okay, here we go. So back in anatomical position, thumbs pointing out. Okay, this is lateral. So away from the midline of the body. This is the midline here. Okay, so ultimately anything towards the midline, okay, is going to be considered medial. All right, let me just hit my little thing here. Towards the midline is considered medial. So for example, okay, my groin in here is medial to my hip out here. My hip is lateral to my groin. Okay. Okay, my MCL in my knee here is medial to my LCL in my knee out here. Okay, my thumb is lateral to my pinky. Thumb is lateral to my pinky. My middle finger is medial to my index finger. Okay. Okay. Now, what about if we're on the trunk? Okay, if we're talking about anatomy in the trunk. Okay. So, for example, if I'm talking about a trunk, okay, neck, trunk, head. All right. Ultimately, moving up towards my head is superior. Moving down towards my tail is inferior. Superior, inferior. Okay. Now, here's the deal. There are some from the osteopathic school of thought that will refer to this as cranial and caudal. If any of you who want to go to medical school, go to an osteopathic medical school, which I think is a great option, by the way. I'm a big fan of osteopathy. I use it a lot in my practice. Okay, you're going to learn superior and inferior as cranial and caudal. Cranial toward the head, cranial toward the tail. Okay, superior, inferior. But, okay, what if I'm talking about an extremity, like an arm or a leg? Okay, my shoulder is superior to my elbow. Okay, my wrist is, sorry guys, scratch that. I was still on the other slide. So my shoulder is proximal to my elbow. My wrist is distal to my elbow. Okay, so my elbow is proximal to my wrist. My shoulder is proximal to my elbow. My wrist is distal to my elbow. My fingers are distal or further away from my wrist. Proximal means further up. Distal is further away. Okay. Anatomical planes, guys. Okay, so we actually live and work and move in anatomical planes. All right. So I've got planes, right? I've got one plane that divides me in half, just like this, right down the middle. This is called my sagittal or my mid-sagittal plane. You hear it called both, okay? Now, here's the deal. In my sagittal plane, okay, my sagittal plane divides me like this, cuts me like a loaf of bread, right down the middle, okay? And if I'm gonna move in my sagittal plane, I'm gonna move anterior, posterior, anterior, posterior. Okay, I move anterior along the sagittal plane and posterior in the sagittal plane. Okay, now, if I have a coronal plane that cuts me in half like a loaf of bread this way, with my face in front and the back of my head in the back, okay, now I'm in a coronal plane. Within a coronal plane, I can move this way, I can move that way, this way, that way. I move medial to lateral, okay, in a coronal plane. Okay, now also, I have a transverse plane that cuts me in half like this, my trunk from my legs, okay? Transverse plane. Now, along the transverse plane, okay, I can also kind of rotate in the transverse plane, okay, forwards and backwards, okay, anterior and posterior in the transverse plane. All right. Well, that was fun. That was super stimulating, right? Okay. So we already went over this, but here's just a biomechanical illustration of how we move in planes. Okay, so when we study movement, right, and this doesn't necessarily relate to this class, but I'm sure you guys covered this in biomechanics. For those of you who took that class, gasp, you probably covered movement in these planes, right? Anterior, posterior. Okay. All right, guys, cavities, not the ones in your teeth, the ones in your body. Okay. All right, friends. So look, cranial cavity. The cranial cavity, believe it or not, is within the inner walls of my skull. And the spinal canal. Inside of that cavity is CSF, okay, cerebrospinal fluid, in which my brain and spinal cord float. Okay, the pleural cavity, okay, that is where my lungs live. My lungs live in the pleural cavity, okay. However, once I hit the diaphragm, which is below the lungs, okay, underneath the diaphragm is my abdominal cavity, all the way down to my pelvic floor, okay? And then from the pelvic floor to the rectal opening at the back is the pelvic cavity. Okay, so once again, cranial cavity, okay, skull, okay, spinal canal, excuse me, and inside of those cavities is cerebrospinal fluid, in which my brain and spinal cord float. Okay, the pleural cavity, and there lives, my lungs in the pleural cavity, the abdominal cavity, my abdominal organs, pelvic cavity, bladder, urinary organs, reproductive organs. Okay. All right, here we go, friends. Even more fun. Okay, this is actually an anterior view of body cavities as well. Here's one we didn't cover. Okay, the mediastinum. Okay, what is the mediastinum? Okay, the mediastinum takes the chest and divides it in half, left and right. Okay, so for example, all right, here's my, well, I'm not going to show you my chest, but I'm going to unbutton my jacket. I'm going to kind of use this as an example. Okay, my lungs are here. Okay, in the middle of my lungs, okay, right here, is my heart. Okay, and then right above the heart, right, is my, obviously, thymus, my esophagus, trachea. Okay, this whole area is my mediastinum. Okay, it's going to divide the chest into left and right pleural cavities, right pleural cavity, left pleural cavity. Okay, cool. I hope that's clear / helpful. Good stuff. All right. Next slide. Oh, we're done. Look at that. Okay, cool. Lecture number dose, guys. Very good. Okay. So I will, yeah. Thanks, and we'll move on to the next one.